All right, let's talk about the brains inside pretty much everything we own. You know, the little computers making all the decisions in our cars, our coffee makers, you name it. But here's the thing, they are not all created equal, not by a long shot.
I mean, just look around you. We're living in a world of smart everything, right? Your washing machine, somehow it just knows the perfect cycle. Your remote control, your smart thermostat that learns your habits. All these things are designed to do one very specific job and do it well.
So, what's the secret sauce? What's the tiny brain actually running the show? And it's easy to think, oh, it's just a tiny computer chip, but the real story is way more interesting. It's all about picking the right tool for the job.
Okay, so let's start with the undisputed champion, the go-to solution for engineers looking to add a little smart to something. We're talking about the microcontroller, or as you'll hear it called, the MCU.
So, what exactly is an MCU?
Well, the easiest way to picture it is as a whole computer, but shrunk down onto a single tiny chip. I'm not just talking about the processor. The memory, the ways it talks to the outside world, it's all in there, all in one neat little package. It's a specialist, built to do one thing and one thing only. And this all-in-one design has some amazing benefits. Because everything's integrated, it sips power, like barely uses any at all. It's also super cheap to make. This is why MCUs are perfect for those simple set-it-and-forget-it devices, you know? Things that run on a battery and just need to work reliably, day in and day out without any drama. So, problem solved, right? For a huge number of gadgets, yeah, the MCU is the perfect brain. But what happens when you want your device to do more? What if its ambitions are a little bigger than just blinking an LED or reading a sensor? Well, that's when you slam right into what you could call a power wall. See, the very thing that makes an MCU so great, its simplicity and efficiency, suddenly becomes its biggest weakness. It just doesn't have the muscle to run a full-blown operating system like Linux, or power a fancy graphical display, or multitask like a champ. For those bigger, beefier jobs, you need a different beast altogether. And that brings us to door number 2, the microprocessor, the MPU. Think of this as the high-performance engine. And this is where you can really see the core difference. If the MCU is a self-sufficient Swiss Army knife, the MPU is more like a world-class chef's knife. It's just the processor, the incredibly powerful core. But it needs a whole kitchen of other components around it. External memory, storage, all that stuff. And this modular approach is what gives it so much raw power and flexibility. This quote just nails it. The MPU mindset is all about starting with your software. You don't pick the chip first. You decide what you want the device to do. Want to run a full version of Linux? Need it to handle complex graphics for a beautiful touchscreen? Well, those big software dreams are what point you straight towards an MPU. So for a long, long time, this created a major headache for designers. It was a classic dilemma. You had these two camps, the simple MCU and the powerful MPU, with this huge, empty space right in the middle. And that gap meant you were always making a painful trade-off. You could go with the easy-to-use, cheap MCU, but you had to live with its limitations. Or you could take the plunge, go for a powerful MPU, and suddenly your project gets way more expensive, way more complicated, and it just eats up battery life. There was no happy medium. But what if you didn't have to choose? What if you could actually bridge that gap and get the best of both worlds? Well, that exact question, that need for something better, led to a brand new, really innovative type of chip. And here it is, the crossover processor. The name really says it all, doesn't it? It's a hybrid. It's designed to give you that MPU-level muscle and performance, but with the MCU's friendly ease of use, low power consumption, and that super fast real-time control. And look, the proof is in the pudding. When you look at the performance per watt, basically how much work it gets done for the energy it uses, these crossovers are in a different league. We're talking a huge leap in efficiency, like 2 to 4 times better than what came before. And here's the kicker. They get that amazing performance without sacrificing real-time control. They have something called incredibly low interrupt latency. Now, that's just a techie way of saying they can react to things happening in the real world almost instantly. We're talking 20 nanoseconds. That's the kind of responsiveness that used to be strictly MCU territory. Okay, so this is the part that sounds a little bit like magic. More performance, but a lower overall cost? How is that even possible? Well, it all comes down to some seriously smart design choices. So here's the secret. That built-in flash memory you find on a lot of chips, turns out it's really expensive to manufacture. So the designers of these crossover chips did something radical. They just got rid of it. Instead, they used modern, more efficient manufacturing to cram a ton of super-fast onboard memory, called SRAM, right onto the chip. This one move eliminates the need for a bunch of other pricey external parts, and boom, the total system cost drops. And this really shows you the payoff. Even when you factor in buying some cheap external memory to go with it, the crossover processor delivers 3 to 5 times more performance for every single dollar you spend. That is a massive increase in bang for your buck. Okay, so this is all cool tech, but what does it actually mean for you and me, for the stuff we use every day? Well, it means the doors have been blown wide open for a whole new wave of smart devices. Remember that big gap we talked about? Crossovers are filling it perfectly. They're the reason your new smart appliance can have a beautiful, responsive touchscreen. They're what's enabling crystal clear, high-end audio processing. They're giving drones and 3D printers incredibly precise motor control. And they're doing it all without making these devices crazy expensive or killing the battery in 5 minutes. So the real takeaway is this: the crossover processor isn't just a slightly better chip. It's a whole new category that's making things possible that were just too hard or too expensive before. And that leaves us with a really fun question to think about. As this kind of power gets cheaper and easier to use, what's the next everyday object in your life that's about to get a serious brain upgrade?